Alright, I think it's time for the final push to get this set done. Now, there's one area that I haven't done anything with, and that is this high voltage cage. Haven't checked the tubes, haven't cleaned it out, haven't done anything, so that is definitely on the short list of things to do. I'm going to remove these sheet metal screws to get this cover out of the way. Then I want to clean it all in here. In particular, I want to get rid of all of this. We got high voltage here, it's high voltage rectifier, and more of this crud you get, dust and fluff and whatnot, the more chances you have of there being arcing underneath there. And I want to check these tubes, replace them if they are bad, especially the horizontal output tube, which does not appear to be the original. And that's where I got bit. About 5 days later, still very visible. And I want to check that big power resistor. On just about every Admiral set I've ever worked on, the 30 series and the 20 series chassis, that resistor has been open. And when it does, you get really weird linearity issues, which this set does not seem to have, but the width is diminished now after doing some more recapping. There is a width control, but it generally doesn't have all that much of an effect on it. It's kind of just to fine-tune the width. So I lost some width somewhere, so that could be a weak horizontal output tube, but there's also a few more caps to do, particularly this guy and this guy. So that's the other thing on my list to do. And I want to check a few more resistors and clean the tube sockets, either with deoxit or maybe some of this stuff. Deoxit, a little expensive. This I can get locally, not so expensive. Just basically take the tube out, spray that down into the socket, and on the tube pins, and then work the tube back in. This one looks pretty clean, but seem to be some issues on the sound, particularly this tube, where I've got some contact issues. So I want to make sure it's all nice and clean. And speaking of cleaning, I should probably clean some of this dust off the chassis too. I'm not going to go to the lengths I've gone in the past on some of these with removing all the rust and whatnot and repainting the transformers. I'll clean it up and make it look better, but I'm not going to repaint it right now. Eventually, though, I would like to repaint the top of this transformer shell at least to stave off the rust. The rest of it's pretty rust-free. I see one spot right there. Otherwise, the dust seems to have protected things pretty well. Also want to clean this dust off. High voltage, ground. Get enough of this built up, you can start getting arcing in here. Oh, and I think I should be gluing this base on now. Obviously, the picture tube's working. Not so great, but certainly a watchable image. So time to glue that off. Oh, a few other odds and ends. Just notice there are 2 screws missing on the tuner. Also, check this out, where the twin lead goes to the antenna inputs. There's no way that's factory. It's way too sloppy and fraying. This makes me wonder, is this a replacement tuner? For sure, I want to clean that up. Luckily there's plenty of length here. I can just cut this off, strip it back, and tin it, and do a neater job on that, and replace those 2 missing screws. And also, don't let me forget, gotta reinstall the nuts that hold this IF transformer shield down. Keep forgetting to do that. Otherwise, over here as well, just more dirt to clean off. Oh, and see if I can dig up a cover for this. Now, it's not metal, it's just fiber, thick fiber board. And I believe they put that in there so you can get down and clean the contacts. Here's the adhesive I was talking about that I use for the CRT base. Poked a hole in the tube, took a toothpick, laid a bead around and wiggled it a bit. This stuff is designed to flow, kind of has a wicking action, so it'll creep down into that seam and do a good job. I'm not sure how long it takes to cure. Let's see. Let try for 1 hour, fully cured in 24 hours. So let that sit for a day. Meanwhile, I'll move on to this. I already pulled the 6BG6 and it tests really good. There is a fuse down in there to protect the flyback, which looks to be in pretty good condition. So it'll mostly be a matter of just getting the dust out of there. And I think there's a resistor buried underneath this socket. I'll check that and replace it if need be. Same goes with this. Now, I did finish replacing all the electrolytics. Had no effect on the width whatsoever. I'm still short about ½ an inch on either side. And there is a width and linearity control down here. And I noticed that the controls, they're loose. This one's completely knocked out. So kind of cheaply made. There's a metal cap that has a couple prongs. So you poke it through this hole and the prongs should snap out to either side and kind of hold it firm. This one got mashed in, and this one's kind of loose. So I want to make sure that the width control is even attached and has continuity, because that could definitely be a problem there. Here's a look inside the high voltage box. I just had to remove a few sheet metal screws and it lifts off. I blew out the dust with some compressed air and used some Spray 9 multi-purpose cleaner to clean off these ceramic insulating mounts. Whatever was on them seemed to really be caked on, so I had to use some Q-tips and that Spray 9 to get it off. Now we can finally take a look underneath this high voltage rectifier. There is what they call a doorknob cap. It's a ceramic capacitor that can withstand high voltages. They're very typically rated for 500 picofarads at 15,000 volts or 20,000 volts. And there are also two resistors underneath this socket. One of them is in parallel with the high voltage rectifier filament. I believe that's to reduce the chances of it burning out. The power for this comes from one loop of wire around the flyback. So if there was a surge there without that resistor, or maybe when the tube is cold, there's a chance it could burn out that filament. Otherwise, these generally last forever. They don't have a whole lot of current going through them. Now this guy is something you definitely want to check. That is in series with the high voltage lead, so got the rectifier tube, filter cap, and then this resistor going over to an unused lug, and that's with a high voltage lead. It's a 1 meg resistor in there to, I guess, limit the current. There's very little current going through it, even with a 1 mega ohm resistor in series with it. It really doesn't affect the voltage much. These can drift high, which will then definitely affect your high voltage output. Alright, as for the rest, this actually tests good. It was measuring about 6,200 ohms, which seemed odd because the schematic calls for 8,500, but then I dug through service info and found out that the earliest revisions did indeed use a 6,200 ohm. So that's not the source of my width problem, apparently. Now I did go through the original factory service info from Riders, and there's a whole troubleshooting section, and part of it mentions what to check if you don't have sufficient width. Well, that's one of the things. And also these two coils, horizontal output tube, but also the horizontal oscillator, as this provides a signal that powers this tube, which powers the flyback, which powers the yoke, which sweeps the electron beam back and forth. So I did recap around this tube. I did test this tube, but I didn't thoroughly check the resistors on it. So that would be worth doing. Also be worth swapping out this tube, even though it tests good. The only true test is in a running set. And finally, I need to check that width coil, make sure it has continuity. Let's look at the schematic again. Trying to find that width coil, this linearity coil. Ah, there it is. So this one's a little bit odd. I'm more used to seeing width controls that are just two leads, and they're in parallel with a section of the flyback, and they're used to kind of tune the flyback, so to speak. But this one, actually has a primary and a secondary. So I got to make sure I have continuity on both of those. And there's that power resistor, R444, which says see parts list. That's the one that had a value I wasn't expecting, but indeed it does have continuity, so that's alright. There's that 500 picofarad doorknob cap and the 1 meg resistor going off to the CRT anode. Otherwise, everything looks just fine under there. I'll finish blowing off the last of the dust and put it back together. But only after I replace those 2 resistors. They do check all right. This is maybe 20% high. I'll just as soon replace it while I've got this all exposed. I finished cleaning up inside the high voltage box and replaced both those resistors, and now I'm returning my attention to the insufficient width issue. In particular, I've been going over the horizontal output tube, which is right down here, and I realized I neglected to test and replace a couple resistors, 68 ohm and 100 ohm. 68 is measuring closer to 90, and the 100 is measuring more like 175. In other words, they're both much higher than they should be. And those are both pretty key to the operation of that tube. The 68 is in series with the grid. The sawtooth voltage that drives that horizontal output tube goes through that resistor. So if it's too high, it can reduce the amplitude, which would reduce the power getting through to the flyback, and you get insufficient width. That 100 ohm is going to, I believe, the suppressor, which is another key voltage to this tube operating correctly. So I'm going to replace both of those and power this thing up and see if that resolves the issue. Also, here are those 2 coils I had mentioned that are pretty loose, and I have not checked the continuity on them. I still need to do that. So I'm hoping, here are the 2 metal ears on it. If I bend those out, maybe tweak these a little bit, and I can get these to lock in and seat properly. I replaced those resistors, and hey, we've got full width. However, they didn't fix the problem. In fact, there was no problem, as we shall see in a moment. For testing, I've been using MeTV and watching vintage programming, and it was showing up with about 1 inch chopped off of either side. And when I powered the set back on just now, I had the same problem. However, I left it on long enough for it to jump to commercials with the modern widescreen format, and look, we have full width. It turns out that the way I've got my converter box set up for the aspect ratio stuff, or the way they're broadcasting the signal, it's actually chopped off on the sides. So as soon as they get back to the vintage programming, you shall see what I mean. So you got to be careful with that when you're mixing and matching widescreen and NTSC formats. In other words, the 4:3 aspect ratio the set was designed for, and the 16:9. The way they broadcast stuff these days, well, they got 2 choices. They can either chop off the sides and have full width, or full height rather, or they can zoom in, which is what they typically do, in which case you lose a little on the top and the bottom, I believe. Or like this, when it's, so now we're looking at widescreen, and notice there's a black band top and bottom, so it's like letterbox, but it fills the full width. Now we're back to vintage programming, and hey, it's lopped off on the side and over here as well. It's also a little off center. So I was fooling myself all along. There was no width problem. It was just my signal source. Looks like it's also chopped off on the top. It's like the whole image is kind of shrunk. So what's left to do? Well, since I cleaned the tube sockets and made sure everything was connected tightly, the sound doesn't seem to be cutting out anymore. So that's been dealt with. I do want to pop the cover off of the video IF and check the resistors under there. I want to replace the damaged power cord so I can put the shield back on, or cover rather, so I don't get shocked again. And I want to clean the controls with some deoxit. And I guess I'll go with this for now. It doesn't, even as ratty as it looks, it seems to be working alright, so I'm just going to leave that alone. Alright, now let's see about putting a power cord on this set. Here are the remains of the old one. There's a little stub left of the cord. Then we see some ears and some brass rivets, and on the other side a couple brass sleeves. Well, those slide onto a couple pins on the chassis. They call that an AC interlock. The idea being, if you take this cover off, you can't power up the set. It's for protection of people who go tampering around inside these TVs. Well, servicemen want to work on these sets without the power being applied, so that's why they came up with what they call cheater cords. And a true cheater cord actually is not one of these. A true cheater cord is one that would go into the back of this and then into the set. So you'd still use the set's original power cord, and then you would cheat the interlock by going between this end of it and the chassis. But over the years it's kind of devolved to where people call these cheater cords. But no, really these are just replacement power cords. Luckily I've got the right type. These used to be really common, dirt cheap, not so much anymore. The supply has really dried up and the price has gone up considerably. If you can find one, expect to pay $15 or more for one. Keep your eyes open on eBay or check out surplus sales of Nebraska. Specifically, this type has got the ears and it's non-polarized, and the ears line up perfectly. Why do you care? Well, if you're careful, you can chew away at this old cord and leave the brass rivets intact. Heat this guy up, the vinyl will soften enough you can push it over those rivets. It'll be just like the original. And these will fit just perfectly under the pins on the chassis. If you can't find one of those, well, there are other types. This would be the other common non-polarized type. This is meant to go into a rectangular hole in the back of the set, and then like a C-clip would slide over it to hold it in place. But the pin spacing is exactly the same, and you don't have to worry about the ears. If you chewed this out, the opening on the back would be big enough that you could just push this through, or forget about this altogether and just plug it right into the back of the set. But I do recommend at least make an effort to find one of these if you can, if you've still got this part of it intact, because you'll see when I get this on there how nicely it works out. So how do you get those remains out? Well, take an implement like these little nippers and just start chipping away at it. Also a heat gun can help soften this up, and you might be able to even just push it right off. Now in my case, this old vinyl is so dried out and brittle, it's just crumbling apart very easily. So I'm just using some needle nose pliers here. Just slowly break it all apart. now let's get the new one on there. Not sure how old this is. Still fairly pliable. Columbia Electronic Cables, New Bedford, Massachusetts. No price or date code that I can see, just catalog number. Anyway, so now the task is to get this onto that. So I'm going to get out a heat gun and heat these up. Some guys have said you can put it into boiling water. I tried that once and it just didn't quite get it hot enough and mushy enough. Plus having a pot of very hot water around the workbench is kind of a recipe for disaster. So I like using a heat gun on low.